Hello everyone. Today we'll be continuing with our session on the theory of polynomial. Yesterday in our last video we talked about quadratic expression and quadratic equation and how the different roots are formed by the values of the coefficients that we understood, and we also discussed somewhat about the discriminant of a quadratic equation. So today we'll be basically discussing that how the nature of the roots of a quadratic equation is dependent on the discriminant of a quadratic equation. So let's start off with it. So the first thing that we need to know is that discriminant is, let me use another ink for it. So discriminant is normally given by, so if we have a quadratic equation of the format ax square plus bx plus c equal to 0, then the discriminant, which is d, is given by b square minus 4ac. So this is the thing that we need to remember. So now, depending upon the value of d, so if d is greater than 0, so if d is greater than 0, that implies that the roots are real. Basically, roots can be real if d is greater than equal to 0. In that case, roots are real. But the thing is that if d is greater than 0, then the roots are real and unique, and if d is equal to 0, that implies that roots are real and equal. So this is the thing. Now the next thing that comes up is that if we have d is less than 0, so what happens if the discriminant of the quadratic equation is less than 0? In that case, the roots are imaginary. In that case, the roots of the quadratic equation is imaginary. So these are the basic conditions for the nature of the roots. Depending upon if d is greater than equal to 0, then the roots are real, and if d is greater than 0, that means the roots are, obviously we have already mentioned that the roots are real, but it is unique also. And in the next case, if d is equal to 0, that will imply that the roots are real and also equal. The next thing that we need to know is that if d is less than 0, then the roots are imaginary. So these are the basic things you already know. I'm just trying to recap it so that we can solve or get into the other concepts much more easily. So if you're finding these concepts already, you're done with it. Nevertheless, you can watch it again just to refresh your knowledge about the same. So anyways, let's continue with our discussion of the nature of roots. Now, what happens if d is a perfect square? Now, if d is a perfect square, that will imply that the roots are rational. If the discriminant is a perfect square, then the roots are rational. This is one more condition. And another condition is that if d is not a perfect square, in that case roots are irrational. This is one more condition that you need to know, that if the discriminant is not a perfect square, in that case the roots are, obviously they're real, but they're irrational. And if the d is a perfect square, in that case the roots are rational. So these are basically the nature of the roots depending upon whether d is a perfect square or d is not a perfect square. Now moving on, one more important thing that we need to know is that I have already mentioned that we are talking about this quadratic equation in general. So now the sum, let me write it over here, sum of the roots is given by minus b by twice a. So this is the sum of the roots, and if we need to find out the product of the roots, that will be equal to c by a. So as you can see, this is very straightforward to say. Now, since we already know that the roots are of the format of minus b plus minus root over b square minus 4ac by twice a. So as you can see over here, if we add this, if we add both the roots, then this plus minus part gets cancelled, and we have I committed a mistake over here. The thing that I should have written is minus b by a and not minus b by twice a. So this is the mistake that I committed over here. So as you can see, this will be, upon adding these two things, this will be basically alpha and beta, which were the roots that we discussed previously. So this will be equal to minus b by a. So this is the structure that we're looking forward to. So let me rub it out. So now as you can see over here, we have written that the sum of the roots is equal to minus b by a. Now what happens if the sum of the roots is 0? Now if the sum of the roots is 0, that means that minus b by a is equal to 0. And if minus b by a is equal to 0, that means that b is equal to 0, since a cannot be equal to 0. So another condition that we need to imply over here is that if b is equal to 0 in ax squared plus bx plus c equal to 0, then sum of the roots is equal to 0. This is one other condition that you need to remember, that if the coefficient of x in ax squared plus bx plus c, in this case it is b, if that is equal to 0, and then the sum of the roots is equal to 0. This is one more case. And another condition that we need to know is that what happens if the product of the roots is equal to 1. Now if the product of the roots is equal to 1, so that will imply us that c by a is equal to 1, and that will imply that c is equal to a. So if c is equal to a, in that case we get that product of roots is equal to 1, and product of roots is equal to 1, that means that basically the roots are reciprocal to each other. So this is the condition that we get. So if c is equal to 0, then the product of the roots is c is equal to a, then the product of the roots is equal to 1, and that will imply that the roots are reciprocal to each other. So fairly easy concept. I hope you have already been able to grasp it fairly well. And one more thing that we need to know is that what happens if the product of the roots is equal to 0. So if the product of the roots is equal to 0, that means that c by a is equal to 0, but a cannot be equal to 0, since that is coming from the definition of quadratic equation or expression. So that will imply that c is equal to 0. So we can write that if c is equal to 0, then that will imply that product of roots is equal to 0. This is one more condition that you need to know. Now we'll be also talking about the rational roots, how they occur, and the imaginary roots, how they occur. So first, let me rub it out. Let me rub out the top portion at least. Okay. So now, this will be basically, so we were talking about nature of the roots. So this is our topic. So now the next condition that we will be talking, that if p plus iq, if we have an imaginary root of format p plus iq is a root of ax squared plus bx plus c equal to 0, then that will imply that then p minus iq is also a root of ax squared plus bx plus c equal to 0. So this is our standard stuff that we already know. So what does this statement also imply? So this statement basically implies that imaginary roots occur in pair. So if we have p plus iq, one of the imaginary root, then we have its conjugate. So p minus iq is basically the conjugate, then that is also the root of this equation, and in that case we'll have that imaginary roots occur in pair and the roots are conjugate to each other if they are of the form p plus iq and p minus iq. So fairly straightforward, and this can be further extended to roots of the format. So if we have, suppose we have roots of the format, if p plus root over q, so if we have a root where p plus root q is a root of ax square plus bx plus c equal to 0. So if we have a root of the format of p plus q, then that will imply that p minus root q is also a root of this expression. So this is our standard stuff that we are going to know. So I hope that you've understood regarding the topic of nature of roots that we've already explained. And if you have any doubt, then you can comment in the comment section below and we'll get back to you. Thank you very much.